start the next lesson now. Coulombs Law. Yeah, Ben? You got this? Yeah? Now, remember that a point charge will produce an electric field. Let us examine the force of attraction or repulsion between the charges. So, imagine here you have a charge, and this is Q1, and here you have a charge, and this is Q2, for example. And let's say, this is negative. So it means there's a field, remember this, a field around this one. Okay, here at this point, the strength of the field is 1 over 4 pi epsilon 0 Q1 over R squared. Okay, but we also have the formula E equals F over Q2. Okay, because there'll be a force here if this one, say, is positive. Yeah? You can put these together and make this formula. F equals 1 over 4 pi epsilon 0 Q1 Q2 over R squared. Now, what sometimes people do is they just call that guy there K. So you can write the formula like this. F equals K Q1 Q2 over R squared. That's the force between the two of them.
So in the test, they will give us K.
Yeah, the value of K is, well, you know this value. I gave you this one already. You know this. The value of K is 8.99 times 10 to the 9. Let me check the units. It'd be Newton meter squared over Coulomb squared. Newton meter squared per Coulomb squared. Yeah? Yeah. Now, this formula is called Coulombs Law. Okay? And it's the force between two charges, and K is a constant. Yeah? So it was Coulombs Law. Now, let's have a look at this picture. So you know this from chemistry. You have a proton here, you have an electron here. And this is moving around. Okay? The force here is equal to K, E, yes, E, because that's E as well, over R squared. Right? What's the force here? F equals K, E, R squared. Now this is interesting. The force here and here are the same. Okay? The electron pulls the proton. The proton pulls the electron. Those forces are the same. But only the electron moves. Why? Why does only the electron move and the proton doesn't move? The mass is different, yeah. It's heavier, so it doesn't move. Now, in fact, in real life, what will happen is it will vibrate. It'll shake. Yeah? Yes? So, What is this picture like? There's something else that this picture should remind you of. Something in,
Earth.
yes, Earth and
Moon.
Moon.
Yeah.
Similar picture, isn't it? That will be important later.
Yeah.
Okay. Ben already knows. Right. Okay.
It's different constant.
Yes. Yeah. Is the constant bigger or smaller? Mm. Mm. Okay. Now, when one charge Q is trapped by another charge Q, oh, let's see. Yeah, goodness. Let's see if we remember. This guy here is trapped. Right? You remember this word? Do you remember this word, Gav? Trapped? What does it mean here about the potential energy?
Is I know the trap in like the meaning. I know in physics. Like always
stay as one time, but
No. You forgot. Potential energy is negative.
free.
You remember this?
Oh.
Yeah.
Oh,
Yeah. Can you write this down again since you forgot it again? Why don't you learn your words? What is wrong with you?
Underline.
We did this in mechanics, remember?
yeah.
Yes.
Yeah. So, yeah, sorry, I just to be clear about my picture, let's scroll down, okay? Let's say this guy here, for example, its charge is plus Q, for example. And this guy here, its charge, we'll say, is minus Q. So because they're opposite charges, they're trapped. Because it's like it's pulling it. Okay. This one here will have potential energy, but it's minus. Okay. So it should be a minus K Q over, not or squared, the formula is just, it'll be or. It's nearly the same formula. The only difference is it's a minus and an or.
Why the potential energy is minus?
Because it's trapped.
But I think it's positive.
No, it's negative, for sure. Now, wait. In chemistry, what do you call freeing the electron? What's that called? When you free the electron?
Yeah.
What's that called? Yeah, what's the verb? Yeah. So, what's the name of the energy you need to free it? What's that energy called? Ionization energy. Remember this word? If you want to free this, you have to give it energy. Why do you have to give it energy? Because it has minus potential energy. Because to be free, the potential energy needs to be 0. Okay, so it's minus because you have to give it ionization energy to free it. Okay. If the potential energy was positive, then you don't need to give it any energy to be free. You just have to go, whoop, and it moves. You know, like this is free, right? Or this energy, what's this potential energy? Is positive, yes? This is positive potential energy. True? Yes?
It's not zero?
No, because it's above the ground.
Ah,
Like if I put it here,
yeah.
potential energy is positive.
Mm.
So it's very easy to move it, right? But now, if I want to get it back here, I have to give it energy. It's like it's trapped in a hole.
Mm.
So I have to give it energy to get it up and out. So it's definitely negative, Ben.
Okay.
Yeah? Okay. Coulomb law gives the size of force between two charges. This force between charges is one of the four forces of nature. So, in nature, there are four basic forces, okay? There's the force between, there's like the earth, and there's you on it. Okay? This force is called gravity. That's one of the forces. Okay, the next one is maybe that's a proton and that's an electron and there's a force here. That force is what we're doing today from Coulomb. Okay, the name of this force is called electrostatic. That's the second force. Okay, there are two more forces and we'll study those later. So far we talked about gravity and today we're talking about this electrostatic force. Okay, I think you should write this word down because you will forget it.
Yeah, I'm started.
Gravity.
Gravity.
Wow.
Ah, you know gravity, don't you?
I know.
Okay, good.
Sure.
Good, I'm happy you know. Yeah? Yeah? Okay, continue? Yeah? Now, I don't really... Okay, no, I can... No. Okay, so look. There is something I want to say in physics. This formula, K, Q1, Q2 over R squared. Ben, you said you know this. There's another formula. Do you know it that's like this?
GMEN2R.
These types of formulas are in physics are very common. You see them a lot. You know, you have a thing equal to a constant multiplied by thing 1, thing 2 over distance squared. These are very common formulas in physics. Okay. Today we did this one. Later we'll do this one. Ben, you said you saw this one before.
What's this?
We'll do it later. My point is they're common structure, common format. You know what I mean? The name of these types of formulas where you have a thing equals constant, thing 1, thing 2, distance squared. These are called inverse square.
Inverse is mass.
Yeah, same word. Formulas.
What's
The word, the meaning is different here.
oh?
Sorry, Ben. The meaning of this, Ben, here is this.
Oh.
Yeah? Continue. Right, so here's an example. What is the force between a proton and an electron when they're 0.1 nanometers apart? Okay? Proton, electron, 0.1 nanometers, and I want to know what's the force. So we look at our formula. I want F. Do we know K? Yes. Q1? Yes. Q2? Yes. And the distance is 0.1 times 10 to the minus 9 squared. Okay. Calculate.
Q is 6.12.
No, it has 1.67, isn't it?
Oh.
1.67 is mass.
Is it? What's
1.602.
1.602 times 10 to the minus 19?
Yes.
It's mass or
Charge. 1.602.
minus 19.
Yes.
Two times two.
Yeah?
41 and 10 minus 8. I think you should have a bracket.
Ah. Let's see.
Oh, it's minus 19.
Minus 19.
Oh, yeah, yeah, that's it. Yeah.
Yes, yes.
And
Oh, yes,
1.44
yes.
What?
Wait.
of
Yeah.
square.
Let's see. Did you forget to square the top?
No.
You sure?
Maybe I wrong.
No.
Yeah, you did forget to square the top. There's no square on the top.
No. Alright.
Really?
Yeah.
It's still 1.44.
Is this one?
Yeah.
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 That's right.
What happened?
Which one's right?
This is right.
Here. It has brackets. No. It's the total brackets and.
Yeah, like here, around the E, is it?
Yeah.
Yeah. Oh, what's wrong, Gav?
Is that K is 8.99 and 10 power of 9.
Maybe you need a circle in front.
No,
of
you know what the problem is? You're using your phone. That's the problem.
No, add a circle.
Where's your calculator?
I can't find
Ah, so you need to buy one.
Somewhere.
Yeah. Yes. Okay, continue.
Smart.
Continue, right.
The last one is stupid. More stupid.
Right. Proton, electron. This time the distance to the centers is 0.2 nanometers. Nanometers, okay? And this goes around. And my question is, what is T, the time?
First, I think.
Just look at
Too hard?
nanometer is -9.
Do you think you know what to do? So, you have F equals K, Q1, Q2 over R squared. And you also have F equals M omega squared R. Yeah, good. And you make them the same.
Yeah.
So you get K E squared over R squared equals mass of electron,
You see?
mass of the electron.
Yeah.
Omega is 2 pi over
Over
T
T.
squared R.
Yeah.
Now you can bring that up there to make R cubed if you want.
Yeah.
Yeah. So and then you can bring the K down here. And then you can bring the E squared down here. And then you can bring the T up. So you can get T equals root ME 2 pi R cubed over E squared, I know they could cancel, times K. So, what's the mass here? It's 9.11 times 10 to the minus 27, is it?
31.
31 times 2 pi times 0.2 times 10 to the minus 9 cubed.
Oh, sorry.
Yeah. 1.602 times 10 to the minus 19
Yeah.
squared times 8.99 times 10 to the 9. Right, what you get? Minus 22. Oh, you have it all typed in there, yeah? Did you square root? No, you did square root.
I think 1.12
1.12.
times minus 50.
No, Ben. No. That's way off.
8.99 is minus 9.
Huh? I think it's looking like this. 3.15 times 10 to the minus 11 seconds. I don't think that's...
Why?
You forgot to multiply.
Sorry.
So, same answer?
1.26.
Huh? Oh. Maybe you typed something in. No! 10, 9. You typed 10 minus 9 at the end.
It's 9?
Yes!
Yes. Oh, okay.
What's the answer for I get the
Oh, no, hang on, why do you have a 2 here?
Well,
You guys are driving me nuts. Right, I'm going to show you how to type it in on a calculator. Look,
it's different again.
well,
maybe that's wrong. I don't know. Let's calculate.
is this?
I don't.
Yeah, we are the
Yeah,
same.
we
Oh.
have the same.
Okay, well, let's check. What did you get?
4.46 10 minus 16.
Yeah, all right.
But I think the first
Yes,
one.
1.46
It is?
minus 10, 16.
It is? Okay, good, fine. Then fine. Fine. Right. My last question then for you. Oh, look here. We don't need it now. It's okay. My last question is, what will be its potential energy of the electron?
Oh, it's all easy.
Yes, so calculate.
Minus.
Yes, calculate. Minus.
Just okay. 1.15 and 10 times minus 8, like 18.
Are you sure? Let's see.
Minus 1.1535. This one.
Oh, actually,
Minus.
Hang on.
wow.
I know I am.
Yes.
This is what you got.
Yeah,
Yeah.
yes.
I forgot the minus.
You're wrong too. Okay.
No, I know the minus.
Okay, fine. That's the potential energy. Yeah?
Mm.
Yeah, alright. Okay.
Mm.
No.
Just the 2 o'clock. Just the 2 o'clock while you sleep.
I'm not sleepy. I'm
Your
Okay.
heart is your heart.
yes,
You're
that's
tired.
it. Yes, my heart is tired, yes.
Yeah.
Okay, there's 10 minutes left. Try these questions for 10 minutes.